following is a quick start introduction to GPR SLICE software. Our first step is to create a new project. We can browse for a default directory, and I'm going to put this on the D drive. I have a folder available, and I'm going to give it a project name. I'm just going to call it Demo 1. We then choose what kind of equipment we have. We're interfaced with every manufacturer worldwide, including their multi-channel systems. This is a Sensors and Software Noggin, so we just hit New Survey, and we created a project for Noggin. Our next step is to transfer data into the project. We browse for the data, and this is on a USB stick. We can just get to the root of the folder, we can search it, and import that data to the raw folder. And all the data is right there in the raw folder. Our next step is to create a new information file. This data was collected along the Y direction of the profile of the grid. It went to 9.5 meters in X and 10 in Y. And we have an option to read the extension number, DT1, and it'll import all the data with DT1 in the raw folder and assign it across this location. So we had 20 profiles, and it went from 0 to 9.5 at a half meter. You can also create information files manually here by using identifiers, and you can create info X direction, info Y direction, and append information files down here as well. Our next step is to go to the Edit Info File menu. We have to do this with every manufacturer. There's a button with the manufacturer's name or italics. Here, SS Get TS, which means Sensors and Software get the time window and the samples per scan for this particular data. So it's reading the header information, 80 nanoseconds on the time window, and a sample on the digitization of 200 samples per scan, which is placed there. You then have an option to go ahead and adjust the line lengths if you need to. You can add lines here or delete lines, whatever is necessary. Our next step is to convert the data. C+. You can change color palettes. Let's say you want to go to a black color palette or grayscale. I can change that to color table 1. I can get out of that and come back in, and then you have a color, a grayscale. There's other ways to change color palettes as well. This particular data is how it's recorded on disk. We apply an AGC gain just to see if the data has DC drift in it. And you can see the signal here is drifting away from the 0 line, and we want to get rid of that low frequency drift. But we won't convert the data with any gain until we do time 0 correction. So we want to hit gain reset, but we want to do this button called batch gain minus wobble. So we're preconditioning the data to dewow and remove low frequency noise. Our next step is we can just look at the grid plot of the data and with the names as well. This particular data, everything was collected in the forward direction, but if you collected the data in a zigzag mode, you would go into this menu and you could reverse all the files if need be. This particular data, we don't have any reversing that's needed, so we can skip the reverse menu. We move over to the navigation menu, and we apply navigation markers to all the data. In this case, our profiles were 10 meters, so we have 11 markers for each radargram. We have to have a marker at the 0 location and a marker at each meter. Our next step is to do time 0 editing. We have a menu that's just dedicated to that because it's very important. We can describe either method 1, method 2, or method 3. Method 1 finds a threshold on the peak response. Method 2 finds the first peak, and method 3 finds the first 0 crossing. I'm just going to use method 1, and you can sometimes have to adjust the threshold here, which means 0.2 would mean 20% of the peak response. For this particular data, we're going to use auto 0 line by line editing, so we're just going to compute an average time 0, but there are options to do scan by scan as well. It goes through all the data and shows the dispersion of time 0, and there's not a lot of change for time 0 for this particular data, but from some data you can see quite a lot of changes. So we have sample 20 and 21 were the maximum, so one sample drift, and here's the corrected data. It then put that corrected data in a new folder called the edit folder, and we have a new information file which has a different time window and samples per scan. Our next step then is to go to the filter menu. We click on the edit folder where we have the new edited radargrams, and we use the button called Spectra plus Gain. And what we do in this menu is we put on an AGC, And then using our left and right mouse, we can set where we want to have our bandpass settings. And we hit the button called Help Set, which adjusts this power spectral curve. So we can cut off low and high frequencies. You may also want to put on one of the stronger profiles on the data to see if it's okay. But right over here you see that we used profile 1 and we have a little bit of a strong gain. So we might want to do an AGC on the stronger profile. And you actually have an option where you can actually come in here and adjust things by hand as well, and because you don't want to have any bumps in it. So here's the gain curve that we could apply to all the data. Okay, after you have that setting, then you run bandpass filtering. But it's bandpass plus gain simultaneously. So we just applied bandpass. Our next step, well, you could do background filters. We're just going to go to do a migration. We're going to go to the search menu, and I'm going to put on radargram number 55. And first of all, if you don't have a hyperbola showing, you have to set the correct unit. And I'm going to set this to meters here, and then centimeters. And then we come back down, and then we have the correct unit that could be shown here. I'm just going to redraw the screen. Size redraw, and we have meters. So there we're matching the hyperbola. If you like that hyperbola match, you just hit test migration to see how well it migrates, and it migrated that very well. We didn't get a good migration there because this is a different velocity. We have options to put in velocity profiles right over here as well. What you would do if you wanted to do a profile, you'd hit reset. You'd first put in the first velocity with a right click, then you put in the second velocity. I'm going to match that velocity there. We right click there, and then you have to put a velocity point at the very bottom by right clicking. You hit calculate, and here's our velocity curve, and you can migrate that data, and you can see an improvement of the migration. Okay, you can also adjust the migration gain. If you want to put on just a little bit more gain, you can hit test migration with a gain of 6. And then we had just a little bit more gain. Okay, from there, what we're going to do is we're going to turn on a multi-thread processing. This particular computer has 12 logical cores. So I'm going to put on multi-thread processing, and we're going to do Kirchhoff migration with multi-thread on. And this will speed up things quite a lot. Okay, multi-thread is done with migration. Our next step is to do a Hilbert transform. We can do that without the multi-thread on, and here's the Hilbert transform of the data. From there, we could actually look at all the data on the screen if we wanted to. We can come over to here. We can say, I want to look at the migrate, Hilbert, Bandpass, and the edit folder. Let's say I want to look at 4 radargrams I have 4 folders at 90% of the screen. I can draw it, and you can see all your different radargrams and the different processes. You also can left click and adjust transforms here and get things to look even stronger if you wanted. You can hit save, and you get more contrast in the data if you want as well. Okay, with that done, our next step is to create time slices. We go to the Slice Resample menu. We'll click on the Hilbert folder. Let's say I want to do 24 slices at 50% overlap on the data. So I would come over to here, say 50%, hit Help Thick. And this will show us how we're binning the data. We're also creating bins every 25 centimeters along the data. You want to have at least 2 to 4 times as much data along the line as between the lines. So we're binning the data that way. I'm going to change my file identifier. Let's say it's the Hilbert folder. I'm just going to call it H for simplicity. I hit Slice XYZ, and I'm making the H time slices. From there, we go to the grid menu, and I'm going to put this on draft quality and a standard search right now. And we've hit Start Grid. We hit Help Set. We hit Start Gridding, and it's going to start putting the time slices to the screen. Let's say I wanted to make do a larger search radius on the data. I could say this is on broader and hit Help Set. I'm also going to turn on the color transform for this data. And we hit Start Gridding. And now we're using a larger search radius for things that look a little bit smoother. I kind of like that look a little bit better. So what I'm going to do is I'm going to put on multi-thread processing and hit Start Gridding. And it's finished the multi-thread gridding. From there, I might want to put on a low-pass filter. I'm going to put on a 5x5 low-pass filter, and we can see that working. And that's getting rid of just a little bit of the gridding noise you can see on the edges there. And it's appending the letter L to all my grids. Okay, the next step that we could do is we go to the T-Slice menu. We're going to look for the LH data, and I'm going to put this on 90%. Let's say I want to look at 24 grids by 4 rows on the screen. That's showing me all my grids. I can check the colorization by left clicking and do an auto gain all, which sets the green bars on the histogram to 3 standard deviations from the mean. So every grid, we're colorizing the most important part of the data. One last piece of information, we have everything on relative normalization, and each time slice has its own scale. You can also put it on absolute, which is based on how you applied gain on the radargram, and the scales will be identical. After we have we had our time slices and we hit this button called auto gain all, we can interpolate between the time slices if we want to make a 3D volume. I'm going to do 5 interpolations here, and interpolate plus 3D file. You can also make more time slices and not do any interpolation and just compile all the time slices to a 3D volume. But I think this works better. We just created a 3D volume, which we can now go into OpenGL, and we have complete control to do things here. We can go up and down with the time slices and the Z-scan. We could put in the X data if we wanted to, and then grab that. You can put on X data, you could put on Y data. We even have an option to put in a rotated scan, which you can make an angle to it and then move it forward and backward. You can actually store that to the screen. You can hit the Z button and you can look at data like that if you wanted to. You could store that. You can also put up a radargram. We need to go to let's put on the migrate data set, and you hit the R button and you can use your mouse like that to move the radargrams across the data. You can hit clear, you can also hit the Z button, you can store it, you can go down a little bit more, you can store it, you can go down a little bit more and store it, and then you can also use this to look between the data like that. Okay. You can also do ISO surfaces. I'm going to put on an ISO surface at 75 and bring it down, and we can make an ISO surface on the data as well, like this. And we also have options where you could store that to the screen. You could put your Z plane on there, and you can bounce up and down there to see how things look that way. We can also do ISO surfaces. Within ISO surfaces, you can say put this on 95 and then hit ISO L, and you can store that to the screen. I'm going to put it on 70, the transparency halfway, then put this on 65. You hit ISO L again, and you can have an ISO surfaces inside an ISO surfaces. So there's many options that you can do in this menu. You can even make animations of the data and export animations and give to your client. Anyway, that's a basic introduction to GPR SLICE software. We highly recommend that you also, on the tutorial page of the website, there's a nice quick start manual that goes through all these steps in about 24 pages, which you can also follow. Thank you very much.